My dear students, today we will discuss about the surveying, which is very important in practical part, and in this surveying we are knowing about the chain survey, prismatic survey and plane table survey, and in this lecture we will discuss about the prismatic compass survey. Now let us see the study outlines. In the study outlines we will see about the what is prismatic surveying, compass surveying, and the importance of the prismatic surveying. Now in this also you will able to know about the traverse method of prismatic compass survey, and also we are able to calculate the closed traverse methods of prismatic surveying. Now first thing is that if you take the prismatic compass survey, it refers to a compass that uses a prism for determining the direction, waypoints and bearing of traveling, while also accounting the angles between them. So this is the what we are calling as the prismatic compass survey. In prismatic compass survey and the surveyor compass, here the prime thing is that two primary magnetic compass included in the collection to assess the magnetic bearing. Now this prismatic compass surveying invented by Captain Carter in 1814, and it is mainly useful for an angular instrument used to measuring the magnetic bearing of a line. And now let us see that. Now you see this slide. In this slide you are seeing that it is a prismatic compass, and this prismatic compass you can observe here, and this prismatic compass is having the cylinder shaped metal box, and this prismatic compass is fixed to the tripod. And now this is the way we will fix it, and the first thing is we will discuss about the different parts of the prismatic compass. So the first thing is that the cylinder shaped metal box. So you can observe here, this is a cylinder shaped metal box, and this compass is a whole casting body or protected by cylindrical box with this is having the diameter of 8 to 12 centimeters, and this metal is made up of non-magnetic metal. So this is about the first part, which is a cylinder shaped box. And next thing is that the pivot. So below the magnetic needle there is a pivot, and this pivot which support the magnetic needle, that is suspended freely, is situated at the center of the compass. So that is a what, and we will see by diagram, we will discuss all these things in detail. Now another one is that the magnetic needle, and this is very important in the prismatic compass. Now this magnetic needle, it is a what is called as this needle when freely hanging on any support, always maintain in its two ends, that is pointed in the direction of the north and south directions. So by this you can measure the angle of the line from the magnetic meridian. And the another part which is very important, that is called as graduation circle. In the figure you can observe that this is a graduation circle, and this is magnetically connected to graded ring made of aluminum. This is completely made up of aluminum, that is marked with 0 degrees to 360 degrees. That is from the south it indicate the 0, and up to 360 degrees it will be given, and to measure all the conceivable line bearings. And this is very important, the graduation circle. And then now we are saying that this instrument we are calling as a prismatic compass. So this compass is having the prism, and this is very important. The graduation of ring can be read using a prism, and compass reading can be taken precisely. It is positioned directly across from the object vane. A prism cap covered the prism hole to keep out dust and moisture. So now by the side eye vane you can see the what is the object vane or object, and by that prism you will get the readings. So, another one important aspect is that here the object vein, you can see the figure, this is called as an object vein and this is called as the eye vein. This part is called as eye vein and this is part is called as object vein. So, now this object vein, the prism and eye vein are diametrically opposed to the object vein. The object vein is carrying black thin wire or horse wire to match up with the object side. When we see from eye vein, now you can see the object through this horse hair and to match the or bisect that object. And then there is a already we know that an eye vein. Eye vein is to view the objects through the object vein. It is a separate an object from silt. An eye vein is a fine silt with a hole for the eye in the bottoms. So, this is very important, eye vein and object vein. So, from the eye vein you will see the objects through the what is called object vein. Now, another you can see here is a prismatic compass. So, on the top there is a glass covering. So, this glass is covered on the metal box. It encloses the instrument box from the top, so that graduated ring and needle are visible from the angle. So, you can observe that at the top there is a glass and below the glass you can have this magnetic needle and also you can have this graduated ring. So, that is visible through this glass covering. And now, another thing is that sunglasses, this is also one of the part we can see in the prismatic compass, and when a luminous item needs to be divided, they are utilized. Suppose now when you are taking the when you are observing the objects, so if anything directly sun rays falls, you can use these sunglasses. By this you can also luminous items can be divided. And the another is reflector mirror. When the bisection is applied to the object vein, it is utilized to obtain an image of an object that is situated above or below the instrument level. So, a reflector mirror is also there in the what is called prismatic compass, and this is called as a reflector mirror, and this you can slide up and down to see the what is called the readings. And there is a spring brake. So, the spring brake is used when this needle almost move from one direction to another direction. Suppose if you press the spring brake, the needle will be like it will be straight in one direction only. So, the spring brake is gently pressing the brake pin in the light spring brake linked to the box is brought into the contact with the wedge of the ring. And then now you can observe here, this is a prismatic compass in the section front view. So, here you can say here this part is called as eye vein and this part is called as object vein. So, in the eye vein what we have observed, there is a prism. Yes. So, in the prism here also there is what is called glasses, and here the opening of the prism. By this only you can, there is a eye vein, you have to see the object through this eye vein, and then this is the what is called as object vein, and object vein as the mirror, and this you can slide up and down based on your objective view. And another thing is, this is the top of the glass, this is a top of the glass or prismatic compass, and then you can observe this is a magnetic needle, here this is a magnetic needle, and this magnetic needle has the position of north and south direction, and this is called as a pivot. So, you can see that on the pivot you can see the needle magnetic needle, and then you will have the what is called as another one, the cap, agate cap. So, on the top of the magnetic needle there is a agate cap, and all these is regarding about the what is called the prismatic compass. And now let us see about all the details about this prismatic compass. It is the most convenient and portable form of instrument. generally fitted on a tripod. So, the first thing is that when the prismatic compass is, you have to fix to the tripod, and this is portable. You can usually carry anywhere to do the surveying, and it is provided with a small right angle prism. That's why we are calling as prismatic compass. And there is an eye slit at one end of the compass, already you are observed, and an object vane provided with the horsehair attached to its center for intersecting the object at the other end of the compass. So, there is a dial graduated ring. Already we have seen that graduated ring about 0 degrees to 360 degrees, which is supported on hardened steel pivot. The graduation of the dial are written in a inverted. They get the reflection through the prism, and here the thing is that now these graduated rings have the readings in a inverted position. So, when we observe from this prism, this will be seen that in a direct form. So, that is the one. A small magnetic needle which is shows north and south direction is attached below the dial, we already discussed. And then now the prismatic compass can be used while being held in the hand. For better precision, we have to fix it to or mount to the what is called as tripod. Now, the compass can be readily positioned with this setup. These three steps are necessary for its function. So, now when you fix this the prismatic compass on the tripod, we have to go through these three steps which are very important. The first thing is that centering is the one, and leveling is the one, and taking note of the bearing is the next step. So, these three steps are important in prismatic compass survey. Now, let us see what is centering. So, already this centering means here now you have to project the ground point, and the ground point should be at the center, and the same the center can be seen in the prismatic compass. So, how we can do this? A small stone is dropped beneath the compass center until it hits the top of the peg. Means you will keep a peg at the ground, and when you drop this stone that falls on a peg. So, at that time only it will be have a centering. So, designating the station. So, that peg is a station. The positioning the compass center vertically over the station point. This is very important. So, initially you have to do centering. Again, after centering, you have to do the leveling, because whatever the prismatic compass you have fixed on the tripod, that should be level. The compass is leveled using a ball and socket mechanism, allowing the graduating ring to swing quietly and freely. A circular pencil may be used to test it against the compass box, or you can use as a spirit level also you can use for this leveling. So, if the bubble comes at the center, that will be in a level mode. So, this is what is called the centering and leveling. And another thing, once if you set up the prismatic compass, you have done centering, you have done leveling, and next step is that you have to take the readings, or you have to take the bearings. So, which is very important. After leveling the instrument and centering it over the station, adjust the prism's height such that when viewed through the prism, the scales on the ring are plainly visible. So, you have to see in such a way that the graduated ring should be visible from the eye vein. The range rod at the forward station must be plainly visible before the turning the compass box. Now, one thing that, so here you have to put station. So, once you have fixed the tripod and prismatic compass, then you have to fix the other stations by ranging rods. Ranging rods, you keep the station, suppose if you take the example, the station A is at the point, and B station, C station, D station and E station. You have to keep the range rods or any object we can see from eye vane to the object vane. Now, here take the readings where the hairline seems to cut the graduation ring after using the breakup pin to stop the ring and bring it to rest. Typically, readings are estimated to be the closest 15 minutes. And now, if you look at what are the advantages of prismatic compass. Now, the advantage is that they are lightweight and portable. Already we have discussed that it is a portable, and fewer settings are available to fix it on a station. Only centering and leveling we can do it, and only few settings is needed to know the readings. And on one survey line's direction in accuracy has to be bearing on the other lines, and another one, it is appropriate to retrace previous surveys. These are the advantages. And the disadvantages of a prismatic compass survey is that it is a less accurate than the cutting edge surveying techniques. It is susceptible to number of inaccuracies, including errors next to magnetic meridian, location attractions, and errors can also result from improper leveling and poor range rod sighting. This also we can get the error. These are the advantages and disadvantages of prismatic compass. Now, let us see what is the bearings. Now, we are talking about all the third step after centering, leveling, you are taking the bearings. So, bearings is very important, and bearings is nothing but the plotting of the objects on the map are done with the help of angles. So, measured through the compass and distance between them. So, these are bearing. The bearing is the angular measurement with reference to an adopted meridian. It may be the true or geographical meridian or the magnetic meridian or assumed meridian. Hence, there are three types of bearings. One is true bearing, one is magnetic bearing, another is assumed bearing. And there are two other types of bearing also there, forward bearing and back bearing, which differs by 180 degrees. So, let us also discuss there are two types of system graduations on the disc. So, in the prismatic compass you will know about the whole circle bearing. This is very important, WCB, and the other bearing also there, quadratic system, and are the two types of bearing which is used in the field of surveying for the purpose of measurement of the bearing. Now, in the prismatic compass we will use WCB. So, that is whole circle bearing. What is whole circle bearing? Let us see this what is called as the figure. In this figure it is showing that the whole circle bearing is having the readings of 0 to 360, 0 degree to 360 degrees. Now, let us how you will determine the what is called bearing in this whole circle bearing. So, in the whole circle bearing you will determine from 0 to 360 degree with a reference to the magnetic meridian in the clockwise direction. Now, this is the clockwise direction, and the whole circle bearing values range from 0 to already 360 degrees shown in the below figure. Example, now you can see here 66 degrees. So, now this is the from clockwise it is 66 degrees, and then another one is 135 degrees. So, you can see here this is a 135 degrees, and another one is 330 degrees. So, this bearing is 330 degrees. So, now how you will take the readings? You will take the reading from 0 to 360 degrees. Now, the first point here you can say 66 degrees, and the second point is of 135 degrees, 165 degrees and 330 degrees. This is called as the whole circle bearing. So, now you can see the direction and a clockwise direction. Now, another bearing, it is called as quadrantal bearing. Now, here quadrantal bearing is also known as reduced bearing, but here we cannot see from 0 to 360 degrees. Here only we can see that north to east, east to south and south to west and west to north. Means here only 90 degrees. Suppose for example, Now the direction toward the east or west direction, either in clockwise or you can also take in a anti-clockwise direction. So suppose you take this from this figure, it is varies from north to east 90 degrees, again east to south again 90 degrees, like that you can have. But how you will do the, how you will name the degrees? You will name the degrees. Suppose this is north and here you are taken readings. So you can read that it is of 35 degrees north, 35 degree northwest, or another degrees 45 degrees in the southeast, and here you will see the readings by the southwest and here in the northwest direction. So this is the difference between a whole circle bearing and quadrantal bearing, but in prismatic compass we will use the whole circle bearing. So now one thing is that when the survey of large area is to be conducted, then one baseline. So there are what is called as, there are different types of methods. Different types of methods of surveying. One is traverse method of prismatic compass survey. So we will see about the traverse method of prismatic compass survey. When the survey of large areas to be conducted, then one baseline is not sufficient. We have to take more than one baseline. These baselines are mutually connected to one another and form a traverse. Thus, the method of surveying in which more than one baselines are involved is called as traverse method. Means you need to have more than one baselines. That type of survey we are calling as traverse survey method. And in this traverse prismatic compass of traverse, there is a open traverse method and there is a closed traverse method. In this open traverse method, surveyor does not come back to the starting station, but in the closed traverse compass survey method, now the survey will come from start point A to again you will come to starting point. So, but here in this method the surveyor does not come back to the starting station. It is also called as route surveying. Open traverse method of surveying is also called as route surveying. In this method, the bearings of the lines are calculated on the basis of the bearings of that line, which has a difference of 180 degrees in its fore and back bearings. If however there is no such line in which two bearings differ by 180 degrees, because when you are taking the, or when you are determining the bearings, foresighting means you are seeing the object from the station A to station B. What is for back bearing? From B to A, when you are seeing or determining the bearing, that is called back bearing. So if you see the difference from fore bearing to back bearing, you have to get the 180 degree what is called bearings, but generally there will be an error. So only sometimes you will get 180 degrees, but if there is any difference of 180 degrees, you have to correct the readings. Now another method is called as closed traverse method. Already I have told that about the closed traverse forms a closed loop, means the starting point and ending points are the same, and used for surveying boundaries of, you can survey the ponds, sports ground or forest. So polygon or area will be covered or surveyed by this closed traverse method. Now let us see the example of one example. Take one example. Here the following bearings were observed while traversing with a compass. Determine the corrected bearings and plot the traverse to this thing. First, initially what I said, that now fix the tripod. On the tripod you have to fix the prismatic compass, and then you have to see the leveling, and also you have to see the centering. Centering means fixing the station. And then now suppose for example the station A, from station A you have to see the station B, and again you have to move to the station B, and from station B you have to see the station C, and here from station B again you have to take the bearing to the A. This is called as back bearing. Means already we have discussed, and in the similar manner when you move to the C and you have to take the reading of or object bearing of the D point, station D, and also back bearing of B. So this is, in this way you have to determine the bearing from the prismatic compass. So you can see this slide here. Now I have taken example. I have taken station A, station B, station C, and station D. Now station A, from station A you will observe the station B, that is called as forebearing. And now forebearing, what is the forebearing here? It is of 134 degrees 30 minutes. So now you note down this reading on the paper or a survey book, and then again from station A you have to measure the distance from by the tape from the station A to station B. Then again the distance is of 12 meters. Here I have seen that 12 meter distance. Now you move to station B. From station B you have to observe the object of station C, and the stations from station C, and from station B you have to observe again to station A. So this is called as back bearing. Here from station B to C the observation or bearing is about 129 degrees, and again the back bearing is of 299 degrees 30 minutes, and again move to station C here, and station C, from station C you observe the distance of station C to station D, and also bearing, and the bearing is 174 degrees 30 minutes from station C to station D, and note down this reading. And again from station C you have to see the back bearing from C to B. So C to B is here. Now again you take the reading of this one C to B, and then the distance is of 14 meters, and again you go to station D, and again D to C you have to D to A you have to measure it, the distance, and also bearing. What is the bearing here? Now the bearing is 276 30 minutes. So this is what is called as you have to take down the reading bearings, and these are called as forebearings, whatever you are observing the stations, and this is called as BB means back bearings, and these are the back bearings. So this is very important. So once I already said that, so when you deduct or when you see the difference between these two, now you have to get the 180 degrees, then only the observations or bearings are correct. But here now because of local attractions there will be some deviation, that is why we are not getting 180 degrees. So this we are calling as local attraction, is the amount of deviation of the magnetic needle of the compass under the influence of external attractive forces, because it is caused due to the presence of magnetic materials such as iron pipes. If the difference between four back bearings of line is 180 degree, both end stations are considered to be free from local attractions. Then another thing is, now you see the table here. What I did is that now forebearing and back bearing, and we have found the what is the difference between forebearing and back bearing, 180 degrees here means the now whatever you are taken the calculation, that is correct, but here there is a difference of 30 minutes, or that is the difference of what is called 2 degrees 30 minutes, and here is difference of 1 degree 30 minutes. So in this way you have to find the error. So after finding the error, what you have to do here, now in order to find out the back bearing is equal to forebearing plus or minus into 180 degrees. So, in this way you have to calculate. Then if there is any deviation, you have to add to that particular bearing, so that the difference should be now you can observe here, after the keeping the errors and correcting the errors, you will get again, you can see that 180 degrees, 180 degrees, 180 degrees and 180 degrees for 4 points 180 degrees. So, this is corrected bearing. Now, the solutions already we have discussed about all these things, how to take the readings, and then plotting we have to do, and after plotting what you have to do, you have to select a scale. Suppose 1 centimeter is equal to 2 meters. So, if the distance between A and B is 12 meters, what you have to do is now it will become the 6 centimeters. So, on the paper you have to draw the 6 centimeters. In this way you have to draw the you have to plot the what is called as map, so that you will get the calculation everything. Now, the second thing is that here there will be some errors. So, errors in compass survey are instrumental errors, we can see personal errors or errors due to natural causes. So, instrumental errors are those which arise due to the faulty adjustment of the instrument. This may be due to the following reasons: the needle not being perfectly straight, pivot being bent or sluggish needle, blunt pivot point, improper balancing weight, and plane of sight not being vertical, line of sight not passing through the center of the ring. These are instrumental. Personal means inaccurate leveling of the compass box, inaccurate centering, and carelessness in reading and recording, and inaccurate bisection of signals. And the natural errors are variation in declaration, local attraction due to the proximity of local attraction forces, magnetic change in the atmosphere due to clouds and storms, irregular variation due to magnetic storm. Now, prismatic compass is an angular instrument used for measuring the magnetic bearings of a line. The greatest advantage of prismatic compass is that both sighting the object as well as reading circle can be done simultaneously without changing the position of eye. The plotting of the objects on the map are done with the help of angles and the distance between them. There are two methods of prismatic compass you are seen. One is open and closed traverse. This type of compass is light and simple instrument and is used for rough surveys where too much accuracy is not necessary. Now, conclusion is that with a portability, ease of use and ability to measure the whole circle bearing, prismatic compass surveys are essential for field surveys, especially in remote and the challenging terrains. While modern technologies have introduced advanced surveying instrument, the prismatic compass remains a reliable and straightforward option for many applications. As surveying techniques continue to evolve, the prismatic compass will retain its significance as a foundational tool, providing essential data that supports accurate mapping and land development. Thank you.